To worksheet number 8, Intermediate Algebra Radical Review. I'm going to try to get you more confident going into your test coming up soon. All right, so we've been talking about this tower in class. The first learning target, simplifying radicals. You can look for a perfect square to go into these numbers, perfect cube, perfect fifth root. I'm going to teach you the tower every time, because I'm assuming that if you're here, you're having a little bit of trouble with them. So I'm going to try to help you with this tower. So if I tower 180, remember I always check 2, then I check 3, then I check 5, 7, 11, and I keep checking my prime numbers as I move along. So 180, I start with 2 and I get 90. Then I do 2 again. I always check 2 again and I get 45. I have to make these towers smaller. Then I try 3, which actually works out to 15. And then I try 3 again and I get 5. So on these towers, when the index here is 2, when we don't see it, the index is 2, we look for pairs. So I circle cross, and if it doesn't have a pair, I cannot touch it. So the circled numbers come outside. If there's more than one, we multiply. So 2 times 3 actually becomes a 6 out front, and then that is the square root of 5. The untouched number goes inside. Okay, now just one time I'll do this. If you saw that the perfect square of 36, root 36 times root 5, if you saw that those were factors of 180, you could have gotten this faster saying square root of 36 is 6. But again, I'm teaching this to the tower here as far as this review goes, so you guys can get better there. All right, so 72. I'm going to take the square root of 72, so I'm going to tower it. Divide that by 2, 36. And now I'm still looking for pairs, so I'm going to circle, I'm going to cross, and I'm going to circle, and I'm going to cross any pairs I have. So that actually ended up being 6 on the outside, and then on the inside, we're going to have a 2. So 6 root 2 is what that is. So now what I'm going to do is this index, again, if we don't see it, there's really a 2 there. So that 2, I'm going to say to myself, how many times can I fit 2 into 11? And the answer is 5. So I take that amount of x's out. That's the power on my x's here. That's the trick we kind of talked about in class. It did not go in evenly. If I fit 2 in 5 times, I'm sitting here at the number 10. I'm 1 away from 11, so I'm going to put 1 variable back inside. How many times does 2 fit into 4? 2 times. So again, the answer to that question is how many variables we take out. Since it went in an even amount, 2 times 2 is 4, we don't have anything left for inside. So that's my final answer to that problem. Okay? All right, moving along. It looks like 162 is my next tower. I'm going to try to make my writing a little bit smaller here. If I divide by 2, let's see, 160 would be, what would that be, 81? And then we divide that by 2. That's not going to work, but 3 does get me 27. And again, you can be firing these in your calculator. It gets easier towards the end. And now since I am having an index of 4 right here, I have to look for groups of 4. I have a group of 4, so I'm going to circle 1 and cross the other 3 factors out. So the circled numbers come out. So circled number comes out, that's going to be 3. And then inside, and I like just kind of writing them like this, separated. Remember, don't forget your index of 4. Inside, we would have the untouched number of 2. So now we do the same rule with the variables as before. How many times does 4 go into 4? 1 time. So I take x to the first out. How many times? And it went in an even amount, so I don't have any left over inside. 4 goes into 10. I can fit 4 into 10 2 times. So that's going to put the y squared. I fit it in 2 times, but I'm 2 away. That would only be at 8. I'm 2 away from 10. So I'm going to say y squared. And then finally, I have the z to the 16th power. Well, 4 goes into 16 4 times. I'll try to fit this on here. Let's make it ugly. But that's going to be, there we go. It's kind of hard to see, but z to the fourth because it fits in 4 times. And then it goes in an even amount, so there's nothing left inside. That's the answer to number 3. All right, cruising right along. We got 48. So if I'm going to tower 48, hopefully you're getting comfy with starting with 2. Always checking 2 until it doesn't work. And then when we get a prime number here, sometimes I see students do this. Watch this. They say, oh, and then they forget. They're like, oh yeah, I wasn't supposed to do that. Well, they forget that the 3 is on the outside. So be very careful as you do that, not to put that hindrance on yourself. So now I'm going to get this read out. I'm looking for triples because it's a cube root. So here's my triple. Circle, cross, cross. I don't have any more triples. So since I only had a 2 circled, I take a 2 out. And then inside, I'm going to have a cube root. I have 2 left over. Remember, when you have 2 items left over, whether they be circled or untouched, we multiply them together. So 2 cube root is 6. And now 3 goes into 5 one time, so 1x in. That will leave me with 2 x's inside, because that gap there is 2. 3 goes into, well, be careful, that's a y to the first power right there. 3 doesn't fit in there at all, so we just leave a y inside. But then 3 does go into the 6 2 times, so we're going to have a z squared out. So this would be our final answer, since 3 went into 6 an even amount of times. All right, here we go. Keep cruising. These should be great now. 128. Let's try to tower 128. If I divide that by 2, I'm going to get 64. I'm going to divide that by 2, and I'm going to get 32. I'm going to divide that by 2. Okay, here we go. Just do this. Wow. We are getting a lot of 2's here. It must be Tuesday. Thank you. You guys know I had to get that joke online. Okay, so here we go. Looking up here, it's a 5th root, so I'm looking for 5. So I'm going to have 1 and cross, 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 cross. 4 cross-offs this time, leaving me 2 2's down here, which I'm going to multiply. So here's the deal. I'm going to take a 2 out. I'm going to have a 5th root. And inside right now, I can put the untouched 2 times 2, which is 4. 5 goes into, it does not. So that's going to leave me just x cubed here, because 5 doesn't go into 3. 5 does go into 13 2 times, so I'm going to have a y squared. Fitting it in there 2 times gets me to 10, which I'm 3 away from 13, so we're still going to leave 3 of those y's inside. So here we go. Final answer to number 5. Okay, number 6, tower and 80. Here we go. Divide by 2. 40. Divide by 2. 20. Divide by 2. 10. Divide by 2. 5. And remember, we're going back now. The reason I gave you the square root again is, remember, there's an index of 2 if you don't see it. So now I look for pairs. Circle cross. Got another pair. Circle cross. So this is going to be a 4 on the outside. And then when we go in the inside here, we're going to have just a 5, 4 root 5. Don't forget about your variables. 2 goes into 6 3 times, so that would be x cubed. It's an even amount, nothing left inside. There's our final answer. Okay, I hope Learning Target 11A is getting better for you, simplifying radicals, both with and without variables. All right, so now these next ones, if you know how to tower, you just got to be careful and realize to add and subtract radicals, I must have what we consider like radicals. All right, it is just like variables. You know, if I put 2x plus 3x together, I get 5x's. Well, if I had 2 root 3 plus 3 root 3, I'd have 5 root 3. It's the same idea. And just like we can't put x's and y's together, we can't put like root 2's and root 5's together. So if we look at this first one, the first step is to make sure all radicals are simplified. Well, I gave you one where they were, okay? Everything was simplified here, can't go any further. So I'm going to look at 9 root 2 and say, oh, there's another root 2 over there. So 9 root 2 minus 2 root 2, just combining those together, I get 7 root 2. And then this one here is root 5, and this one here is root 5. I have negative 7 of them. I have positive 6 of them. I really have minus 1 root 5s. I cannot go further. Okay, just like if this said 7x minus 1y, I cannot put those together. So that's it. That's as far as we can go. All right, and then looking at number 8, same idea, except just be careful. They don't all go together. A square root is different than a cube root. So 9 root 2 and 1 root 2 make 10 root 2's total. 6 cube root of 2 minus 3 cube root of 2, combine them together, that's a plus 3 cube root of 2. And they are not the same, so they cannot go together. Roots that are square roots and cube roots do not go together. All right, moving on to number 9 then. Okay, so if you're getting really good at the tower, I'm going to show the work here, but 20 divided by 2 is 10, divided by 2 is 5. We circle, we cross. Be very careful. I'll try to use the highlighter here. All right, let's see at the yellow here. If we go right here, that, not the 4, but that is what turned, the root 20 is what's turning into 2 root 5. So we literally replace the root 20 with 2 root 5, but it says multiply by 4. You still have to multiply by 4 out front. So when we move through here, we add 6 times root 80. Well, I'm going to save the time on the tower of the root 80. We actually did that one on number 6. After you tower root 80, it will come out to, and hopefully you can do that now, the tower 4 root 5. But again, like looking at this here, these are the things we're replacing. The root 80 is replaced with 4 root 5. The root 20 is replaced with 2 root 5. We still have to multiply here, okay? So outside with outside, 4 times 2 gives me the 8 root 5. Plus, outside with outside, 6 times 4 gives me the 24 square roots of 5. And then at the end here, we actually notice those are like radicals. So we can put those together, and that becomes 32 square roots of 5 because they are like radicals here. All right, I'm going to go a little faster on number 10. It's the same concept. Tower if you need to, but when you simplify just the root 12 here, that's going to become 2 root 3. Simplifying the root 27 here, that's going to become 3 root 3. And then doing our multiplication, we get 6 root 3 minus 2 times 3 is 6 root 3. It actually comes out to 0. Kind of a funny problem there, okay? So 0 was the answer to that one because there's nothing left. All right, I'm going to turn this one off. Please watch page 2 if you need some help with those other learning targets. I hope that helped.